A rectangle has an area of 48 square inches. A similar rectangle has an area of 768 square inches. What is the scale factor of these similar rectangles? So we have two rectangles and they are similar. So I'll just draw one pair of rectangles which are similar. Okay, these are the two rectangles we have. The area of the first one is 48 square inches. The area of this rectangle is 48 inches square or square inches. And the area of the second rectangle is 768 square inches. So now the question is, what is the scale factor of these similar rectangles? Okay, in order to find the scale factor, first thing is I have to find what is the ratio between these two areas. These are the two numbers they gave to us. So let us use them, 48 and 768. And I'm finding the ratio of areas, that is 48 is to 768. Okay, and once you have this ratio, we have to change it or write it in its simplest form, that is 48 and 768. In order to write it in the simplest form, the best way is in this particular case, because I'm looking for a scale factor, it is best for me to divide the first value by that whole number, right? 48 is there, just divide by 48. I'm not concerned whether this 48 divides 768 or not, but let us just go ahead and divide by the first area, that is 48. Okay, so now this 48 over 48 gives you 1. See, I wanted 1 here. Now the next term here is 768 over 48 gives us 16. 768 over 768 divide 48 gives you 16, right? So I'll write down here 16. So this is the ratio of areas. Now, but when you're looking for the scale factor, we actually see for the ratios of the corresponding sides, not the ratio of the corresponding areas, but the ratios of the corresponding sides. What is this sides ratio I am looking for? So from the areas, when I have to go to the ratios of the corresponding sides, I just have to find the square root of those two terms, the first term and the second, that is 1 and 16. Take the square root. So square root of 1 is 1 and the square root of 16 is 4. So this is telling me that the first side, whatever is the measure of the first side of this first rectangle, is fourth of the measure of the second side. Let us look at this example. I mean, in the given problem, I have 48 is the area. Let us say that its length is 8 and 8 inches times 6, I think, yeah. 8 times 6 is 48. Okay, so that 8 becomes 8 times 4, which is 32. So 32 is the length of the second rectangle, and 4 times 6 is 24. 24 is the width of the second rectangle. Verify. Now what happens? 32 times 24, 32 multiply with 24, the product is 768. That is the area of this rectangle, right? So the scale factor, is 4, right? The first side is multiplied by 4 to get the corresponding side of the second rectangle, and the width of 6 is multiplied by 4. So hence you can say the scale factor is 4. What is the process? From the given areas of similar rectangles, first thing is I'll find the ratio. To find the ratio, the best way is make the first term as 1. You made it as 1 by dividing with 48, so that 48 over 48 is 1. Because you divided the first term by 48, I have to divide the second term also by 48, so you got 16. Then in this next step, we had its square root. Taking square root, the square root of 1 is 1 and square root of 16 is 4. Hence, the scale factor is 4. That is, 1 becomes 4. Same way, 8 becomes 8 times 4, 32. 6 becomes 6 times 24. So, please try this next problem. Using the same process, there we have 48 and 768. Those are the areas of the two rectangles. And in this we have 30 square inches is the area of the first rectangle, and 750 square inches is the area of the second rectangle. Please find the scale factor of those two similar rectangles. Thank you. Thanks for watching.